Lists are indexed, so basically the order matters in terms of in which you express it. So indexing with like say our list from last week, where if we took item 0 from it or item 1, you would have a specific value that was attached to it based on the index value. What we do with dictionaries, as opposed to lists, is we create what's called a key value pair. And so what you do is you identify a key and then you put a value in for the value. So it could be a string, it could be um, an integer, it can be a float, whatever kind of information you want to put in there. Basically, you're going to define it in terms of its key, which is basically going to be its index value. So instead of putting a number down, you're going to actually put a string of some sort, and that's going to be attached to whatever you put in here. So for this dictionary, please note that with lists we were using square brackets, but for dictionaries we're using curly brackets. You can define a dictionary by using this DICT with open and closed parentheses, or you can just start creating a dictionary with the curly brackets. So this dictionary, which is kind of the inspiration for this week's exercise and our competition, is creating a English to Spanish dictionary. So let me stop sharing for a second. I don't have a English to Spanish dictionary, but I do have a Finnish to English dictionary. So basically what the assignments and exercises are for is basically your key is going to be the English word that you want, and then your value is going to be the word in the foreign language that you are creating a dictionary for. So just like any sort of dictionary, there's a phrase or a word that we are trying to express, and then there's going to be a definition attached to it. Well, it's a little bit easier here with like a translation where we're going to have the word in English and then we're going to have the word in the foreign language. So for your exercise this week, what you're going to do is you're going to be creating these dictionaries that have key value pairs that are going to be the word in English is the key, and the value is going to be the word in the language of your choosing. But for the competition, what we're going to do is we're going to break you off into groups this week, and then your goal is to create the biggest in terms of number of elements dictionary English to a foreign language within a certain time period that I think I'm going to make it 15 or 20 minutes. And then you can kind of figure out the process to make it as quick as possible. Maybe you're using a phrase book, maybe you just know a foreign language and you're like, okay, what are the most things? And then the reason why the way I'm going to determine the winner is not necessarily based on the largest size, but I'm going to have a few key words that I've randomly already chosen that I'm going to seek in the dictionary of yours, and the team with the most words from my random list is going to be the winner. So having the most might not get you the win, but kind of guessing what words I'm going to be looking for, they'll be more common. I'm not going to be like, okay, what is uh I don't know what is rutabaga in Spanish. Like I don't even know what rutabaga is in English, much less in Spanish. So I know they're in pasties, but I don't know actually what it is, but I've eaten it before. So that's basically what our exercise is going to be this week. But so you kind of know what we're doing. Um, Let me share my my code here. So if you look here, sorry, you all disappeared on me. There you are. So you can either create a dictionary by using just open and close curly Q brackets, or you can just call it a dictionary like this. So if I run it, let me get a print statement here. Okay, that's telling you what class it's in with type. So we both know they're dictionary. So whether we go with dictionary or names with curly Q brackets, we have two dictionaries. So let's print names and see what it gives us. Just gives us an empty dictionary. That's what we want to see. So let's add something to it. Okay. So let's say, remember how with a list, so let's just say, if we were doing a list, we would say, okay, list, we could index things with a 0 or a 5, depending on the number of items that were in that list. But when it comes to a dictionary, what you will do to define something in it is you would say, okay, names, and then you'll do open square bracket, and then in the string value, you'll put the key in. So if I'm saying names, maybe I want my key to be my first name, and then I want the value to be my last name. Okay. So then if we do that, we end up getting an item in the dictionary with my key being my name and then my last name being the value. So if I do that, it's going to print out the value. If I print names and the key, it's going to spit out the value. If I have it the other way, it's not going to give me anything because this is not the key, this is the value. So when you have something that is not a key within the dictionary, it's going to give you a key error. So there's only one name in there. So if I put Bob in here, it's still going to give me a key error. So that's basically your dictionaries, and you can put these in whatever order you want. It's just that it's going to be sorted by keys as opposed to sorted by a numerical index. So let's add another one in here. So let's say names Bob is equal to Marley. Okay. So now if we print names, we should get two items within our dictionary. And so if I want to call names Bob, not BPB, Bob, Bob, there we go. Then we get Marley as the printed out thing. So basically what we're creating is basically keys that are creating our own unique set of indices. So we can make it, basically, it doesn't have to be a dictionary of one thing to another. It can be a storage of a bunch of different types of information. So what might happen is you might have like a list of names in a document, or maybe you have a group of emails and you want to figure out, like, you want to sort how many times that occurrence happened within them, and then you want to store that value in a dictionary. So, for instance, you might say, okay, well, for jobs, how many people are grocery workers? You might end up saying, okay, well, four of us are grocery workers. Okay, and jobs unemployed is 2. And jobs, I don't know, student, well, not student, let's just say you work in tech, is 3. Okay, so now if we print jobs, then we get key values where, okay, well, someone wants to know how many people have grocery jobs. Okay, so I print that out. Boom, 4 people have grocery jobs. So that's basically the simple functionality of this. So what you're going to do with your dictionary is you're going to um, what you're going to do with your dictionary is you're going to basically create the key being the word in English, the value being the word in Spanish as a string. And then what'll happen is I'm going to randomly choose a word and then in English, and then the if the value exists within your dictionary, then it'll pop out an answer, and then that will count as a point for your team. And then if it doesn't, well, then you don't get a point for your team. So you could have a list of 1,000 words in your dictionary, but if the 5 or 7 that I'm looking for aren't in it, um, then you won't get the point. But in order to get credit for the exercise, there is a separate requirement. I think it's the first numbers of 1 through 10, your favorite color, and your favorite fruit. So when you submit the exercise, I want those to be in the dictionary. And it can be whatever language you want, assuming that you can have some sort of Latin alphabet translation of it. So if you want to do like Japanese or Chinese or Russian or something like that, or Armenian where there's like scripts, like you would have to have the Latin alphabet translation of that word for it to work. Um, Maybe you can have Japanese and kanjis and all these other scripts in here, but I am not versed with that. So if it does exist, then by all means. But for this exercise, we're gonna do it that way. Let's see here. What else do I want to share that's interesting? You can also use the length command like you did for last week's exercise to figure out how many elements are in the dictionary. So if I get rid of this, you'll see that there are 3 items within the jobs dictionary. So I can figure out who has the most words by just using the length command within the dictionary. Let's see here. What else? That might be interesting. Next week we can do a lot more with dictionaries once I introduce you to loops, because then we can basically use loops to count items. We can use loops to um, parse elements from dictionaries in the lists and stuff like that. So that's why I said I'm kind of kicking myself for not doing loops this week. Maybe if we have time, I'll do a little introduction on them. Let's see here. Trying to see if there is anything. You can also do you can also ask whether something is in a dictionary. So if you want to know if Bob is in jobs, you can get a Boolean. So let's try that. So I asked if Bob was in jobs and I got false. Why? Because Bob is not in jobs, Bob is in names. So if we put Bob in names, we get true because there's a key in names that goes by Bob. So you can ask it if that is in there. So that's how I'm going to do your guessing. Now, be careful because, again, just like with lists, when you alphabetize and sort, you're going to have it's going to treat capital Bob separately from lowercase Bob. So if I create a name in um, name, oops, names Bob equals the builder, then if I print names Bob, it's going to give me Marley. But if I do lowercase Bob, it's going to give me the builder. So it's case sensitive. So be careful with that when you're doing your dictionaries. I would recommend lowercasing everything. Um, you can edit this similar to kind of what we did or you're doing for your homework, where you could use the str lower command to make everything one all lowercase or all uppercase, so that way all the characters can be alphabetized properly. You could also manually edit it to like append in one that's capitalized and delete one that isn't. Whichever way works for you for the assignment is acceptable to me, but this is something like next week that we'll dig into a little bit more in terms of, okay, how do we clean up our data? How do we manipulate it so that way it does operations a little bit better? So, another, let's see if there's anything else. I think that's good for now. I'll give you a couple more tips when we come back from the exercise. So what I'm going to do is I'm going to set you off into groups again. I think everybody's here. No, we're missing one person. So I'm going to do, I do 4 groups. No, I got to do 3 groups because I want everyone to have at least 2 partners. So we're going to do 3 groups again today, like last week. And then I'm going to delegate to one of you to create a notebook and collaborate. And then as a team, actually, how about I create the notebooks that way it'll be easier for you to work on it together. But once you get to your groups, you have to agree upon a language to use. So it doesn't have to be Spanish. It doesn't have to be any language that's common. You can do whatever language you want. Um, so you have free reign for that. So let me open a new notebook for everybody. List here. Uh, that's the one I want. Yeah. So one thing I wanted to introduce to you was that you have this ability to actually pull out and create a list from things within your dictionary, which is kind of nice. So if you use the names.values command, so if you define a list and then put the parenthetical as names.values with this open, similar to what you do with an input or any or dictionary, you can actually create a list of all of the values within it. You can also do the same thing with keys. You can do names.keys, and then it'll actually terminate these. I run it. Oh, sorry, it's because I have to rerun my code here. Here we go. And now we get the keys. So you can actually take from a dictionary, you can actually create a list of all the words within your dictionary of the keys. You can also do with the values. And then you can actually do items as well. If you do names.items, then it'll actually create a list with the kind of the pairs, bonded pairs here of first name, last name, so key value, key value, key value. Now, this these list items, I'm pretty sure are a tuple, and tuples are immutable. But the thing is you can just but because it's now a list, you can actually you can rename it. You can just replace it with something else. So tuples, which tuples are basically immutable groupings of multiple things for storage purposes. So it's kind of like a list mixed with a dictionary. The only difference is that you can't really edit the stuff inside of it. But if you take a tuple and you pull it out into a list, you can replace the item in the list with something else, which is what I just did here. And then I made my own version of the dictionary. And so I did the numbers 1 through 12 because I knew the list. I did some of the colors, including green, because I knew the list. And then I did some of the keywords of cheese and lunch and computer and Wednesday. So you might recognize all those words. You might not know their Finnish translations, but you recognize the words from the list. Um, so here it is going from English to Finnish. What's interesting, I'm not sure if you experienced this when you were making your dictionaries, but a lot of times, because there's some sort of co-pilot that's built into this interface, you might have been getting suggested like dictionary words to put in there or a grouping of them. I don't know if any of you experienced that or not. But what you have to be careful with is you actually have to make sure that you know that what it's telling you is the right answer. When it comes to like numbers or like colors or something like that, that might be fine. But what I did notice is when I was actually trying to do 12 in Finnish, it actually was giving me 20 as the translation. It wasn't actually giving me the right answer. So I had to know enough to know that it was wrong to be able to make sure that it was correct. So Kaksitoista is 12, but it was trying to give me Kaksikymmentä, which is 20. Um, so here's my little dictionary that I made. Let's see how many words I got in time. 28. So you guys all beat me. So good job. I was too slow with this. I also spent a lot of time trying to take the suggestion of 1 through 10 because if it pops up, you have to like click on it, hit accept, but sometimes it'll disappear on you. And so I wasted more time trying to use the Copilot than it was to actually type things out. So as a pro tip, I would recommend only using that Copilot if you know it's absolutely positively right. Um, because it probably might steer you wrong or make a couple of errors in the process. So let's see here. That's really interesting. So you got a translation into Chinese instead of Spanish. It's really fascinating kind of how these predictors, this text predictors kind of work. Um, so just kind of a random thing. I don't know how many of you are using like generative AI things. So like technically this is a form of generative AI when you have um your co-pilot in here, what's predictive. So what it's going to do is it's going to pull from some sort of generative AI and predict based on a vector what the next word or most likely what you want it to be is going to be. And so sometimes it works, sometimes it doesn't. In fact, actually, I think Setsuman is spelled wrong in mine because I use the Copilot. I think it's AI and not a umlaut, which, so that was wrong. Um, but anyways, when you're using Chat GPT, it's doing the same thing. The way it basically works is it has a very, 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 very large set of information, but it's finite from where it's pulling from. And then it basically translates every piece of information it has into a vector. And so what a vector is it's basically a series of location points in a multi-dimensional space. So you might be used to an XY graph. And so that XY graph, you're used to, okay, like 2, 2 is this point and 2, 5 is this point. Well, it's like an n-dimensional graph. So it's like, I don't know, there's probably 100 or 200 different like points within variables in which it's spacing things out. So every word in every context has its own unique point on that n-dimensional space. And so what it does is it basically sees where one word is located, sees where another word is located, and sees what's the closest thing that's related to those two words, and then it predicts that, and that's what it tells you. So that's all it is. It doesn't really have any sorts of consciousness. It doesn't really have any sort of um, reality in it. It's just basically predicting based on math what the next thing is going to be. The the problem with it is that it's so good at predicting the patterns of human speech that people that aren't aware of it or aren't careful enough start thinking that it thinks and it's conscious and it's telling you and you're having a conversation with it, but it's not really anything. It's just word predictor. So, but one of the things that I thought was really helpful is when I was trying to learn languages, like I'm a Duolingo user, like a bunch of people are. So I like learn a language, meaning I learned like 10 words in like 5 languages, but don't actually know how to use it. Um, One of the interesting pieces to it was like learning Finnish is very difficult, but I maxed out and finished the Duolingo class. So now I'm having to do kind of like traditional methods and like self-learning and using dictionaries and stuff like that. So I wanted practice. So what would give me fresh practice was like just asking GPT to like have a conversation with me in Finnish. And what ended up happening was is it helped me learn in 2 ways. One, if I didn't know what it was telling me, I would ask it, and then it would tell me because I would try to answer back, and I wouldn't be right. So it was like, oh, try again, and I'd be like, I don't know, tell me. But it would also help me in another way because sometimes the translation would be wrong, and I knew enough about it to know that that was a wrong translation. And so I would ask it, I'd be like, didn't you mean this? And it was like, oh yeah, you're totally right. And I'm like, you're not a person, but why are you saying this? Why are you saying, oh, you're totally right? Like, so I'm assuming it's the GPT is trying to mimic a Midwestern teacher or something like that. So, um, but anyways, let me see if there's any other questions in the chat. But yeah, it's definitely AI based. So most AIs are in that technology. So machine learning builds off that, it iterates and tries to basically make the prediction better and better and better using neural networks and stuff like that. But at the end of the day, like these AIs mostly are just word prediction models right now. It's just that because we as humans communicate in word patterns and our patterns are pretty straightforward and pretty predictable. Um, it simulates human speech very well where we think that it's conscious.